Hello, welcome. Today we're going to discuss the Euclidean algorithm for finding the greatest common factor and for finding the least common multiple. Let's start out looking at just how can you find the greatest common factor with the prime factorization. So let's start with that. We're going to do the prime factorization of 60. So I know 60 is even, so 2 will go into it 30 times, 2 goes into 30 15 times, 3, which leaves 5. There's your prime factorization. 2 to the second times 3 times 5. 126. Do a 2 out of 126 will go 63. 3 will go 21. 3 will go 7. So that would be 2 times 3 squared times 7. All right, so now that you have your list, the greatest common factor is just taking all of the common prime numbers and writing them out. So the greatest common factor is they have a 2, just 1 2 in common. 2 2's here, 1 there, so they have 1 2 in common. They have a 3 in common, and that's it. So 2 times 3 is 6. Your greatest common factor for those two numbers is 6. Now, here it says Venn diagram. Remember doing Venn diagrams in the earlier units. If you thought about this with a Venn diagram, you have all the prime numbers that make up 60 and all the prime numbers that make up 126. Well, 60 is, well, they have a 2 in common, and they have a 3 in common, and then you'd need another 2 to make 60, and a 5. So 2 times 2 times 3 times 5, that's your 60. And then on this side, you have the 2 and the 3, so you need another 3 and a 7. 2, 3, 3, 7. So there you're seeing the overlap would be the greatest common factor. All right, so let's look at that again. 792. So if I have 792, I know a 2 can divide out of that. It would go 3 times, leaving 19, so it'd go 9, leaving 18, and 6. Yeah, 18 would leave the 12 and 6 times. And then 2 would go into that one. Go once into the 3, leaving 19. So 9 is 18, leaving 16. So 8. Looks like 2 goes out again. Go into the 19 9 times, which is 18, leaving 18, so 99. 3, which is 33. 3, which is 11. So that is 2 to the third times 3 squared and 11. 308. 2 goes into 308. 154. Get 2 out of that, which will go 7, which is 14, and 77 times. So there's a 7 there, which leaves 11. So that's 2 squared, a 7, and an 11. So the greatest common factor would be 3 2's, 2 2's, so they have 2 2's in common. 3's, no, not in common, and they have 11 in common. So 2 times 2 is 4 times 11, so 44 is our greatest common factor. Again, if you think about that with a Venn diagram, 792 and 308, they have a 2, a 2, and an 11 in common. So 792 still needs another 2, 2 3's, and you already have the 11. So if you multiply all those numbers together, you get 792. 308, you have the 2 2's, the 11, just needs a 7. Alright, so with 3 numbers, you can do the same thing. Let's do 84. Move that up. 84 is 2, which leaves 42. 2, which leaves 21. 3, 7. So that's 2 squared times 3 times 7. 504. 2, which would leave 252. 2 times, which would leave 1. 5 twice, 126. 2 goes into that even number 63 times. 3, 21. 3, 7. So it looks like 2 to the third, 3 squared, and 7. Then 1188. Let's see, so 1, 1. Make sure you can see that. 8, 8. That would be 2. Goes to that 5, 9, 4. Divide 2 out of there. That'd be 2, 9, 7. So that one, 2 is not going to work. 9 plus 7 plus, so that adds up to 18. So 3 will work. 3 go into 29 9 times, which is 27, which leaves 20, so that's 99. Okay, so that's easy. So 3, which leaves 33, and 3, which leaves 11. So it looks like 2 squared, 3 to the third, and 11. So greatest common factor would be they all have 2's, but there's 2 here, 3 here, and 2 there, so they all have at least 2 of them. You can't use 3 because they don't all have 3. They all have 3's, but 1 is the most, so the 1 is the most they have in common. 7 here, 7 here, but no 7 there, so that's it. So 2 times 2 is 4, times 3, so 12 is the greatest common factor. And that's using factor pairs. And of course, with a Venn diagram, for this one, you would have 3, right? So 2, 2, and 3, they all have in common. These two, the 2 2's, the 3, they also 84. Let's see, this is the 84, this is the 504, and this is the 1188. They have a 7 in common that they don't have with the 1188, so 7 would go there. So 84 would be 3, 2, 2. That's 84 already, so I don't need any more than 84. The 504 is 2, 2. It needs another 2, which it wouldn't share, right? It has a 3. It needs another 3, and it would share a 3 here with the 504, and it needs the 7 there. So if I multiply all those numbers, you get 504, and then 1188 needs 2 2's, 3 3's. It already has 2, so it needs 1 more here that it doesn't have with anybody else, and the 11 that it doesn't share with anybody else. So that's what that Venn diagram would look like. And in the middle of the Venn diagram is the greatest common factor. All right. So go ahead to the next page of the notes. If we look at this with factor pairs, and the greatest common factor, it's 180. Factor pairs are 1 times 180, 2 times 90, 3 goes into 60, 4, because you can take half of 90 as 45, 5 because it ends in 0, 36 times. You can do double the 3. 2 and 3 work, so 6 does. Double the 3, half of 60 is 30. 7's not going to work because I don't see any 7's in there. 8's not going to work because I can't take half of 45. They add up to 9, so 9 would work. And it would go 20 times. 10 would work because it ends in 0. 18 times. And 11, no. 12 will work because you can double the 6 and take half of 30. And then 13 and 14, no. So there's your list all the way up to 15. The 240 is 1 and 240. 2 and 120. 3, it goes in 24. 8, 80. 4, half of 120 is 60. 5 and 48. And 6, double the 3, so 6 and 40. 7 doesn't look like it's going to work, there's no 7's. 8, you can double the 4 and take half of 60, so 8 and 39. They add up to 6, so 9's not going to work. 10, 24. 11 is not going to work. 12, you can double the 6 and take half of 40. And 13, 14 is not going to work because 7 didn't. 14, or 15 will work. And I see that 15 is 230, so if you take that 2 with the 8, it'd be 15 and 16. So now you just have a list of all the factors. So what is the greatest one they have in common? Well, it can't be bigger than 180, right? But there's no 180 over here. 90, nope. 60, yes. So 60 is on both lists, and it's the biggest number they have in common. So the greatest common factor for this would be 60. And again, if you think about it as a Venn diagram, you have this is 180, and this is 240. They have that 60 in common, and then they have 3 more, 3 times 60, and they would need 4. And there would be nothing in common in those two, which there's not. Alright, look at that again. Nice long 1 and 252. It's 2 and 126. 5, 6, 7, 8, 9. It adds up to 9, so 3 is going to work. So 3 would go 8 times, which is 24, leaving 12, so it'd be 4. 4, half of 126 is 63. And there I see that 7's going to work, right? 5's not going to work. 6 will. Go 42. 7's going to work. And if I take it out of the 63, that's 9 times 4 is 36. 8's not going to work because I can't take half of 63. 9 is going to work because the digits added up to 9. You could, where if we take 9 out of here, that's 4. And 4 times 7 is 28. 10's not going to work. 11's not going to work. 12, we can double the 6 and take half of 42. And 13, and then 14, because you can double the 7 and take half of 36. 15, no. 16, 8 didn't work. And so that's our list for 252. 540, 1, 540, 2, 270. 3 works because it adds up to 9, so 3 and 9 will work. And 3 goes 1, leaving 24, which is 8 and 0. You can take half of 270, so that'd be 4 times 1, and half of 70 is 35. 5 is going to work, and that will be 108. 6 is going to work because you can take half of 180. 7, I don't see 7's in there anywhere. 8, I can't take half of 135. 9 we said would work, and that'd be easy to take out of the 90. So that's 10, making it 60. 10, of course, 54. 11, no. 12, half of 90 is 45. 13, no. 14, there's no 7. 15, there's a 60. 15 goes into 64 times, so that's 36. 16's not. 17, 18. I can double the 9 and half of 60. 19's not going to work. 20 is. Double the 10 and half of 54 is 27. 21. If 3 and 7 work, then 21 would work, but 22, no, there's no 11s. 23, 24, can't take. 25, no, it doesn't end in 25, 50, 75, or 100 for 25. So that's it. So what is the greatest one? Again, can't be bigger than 252, and that's not on this. 126, nope. 84, no. 63, no. 42, no. 36, yes. So 36 are on both lists. So the greatest common factor of those two numbers is 36. And again, if you looked at the Venn diagrams, 36 is shared by both of them. 7 to make your 252, and 540 would be 15. And those two would have nothing in common, and they don't. All right, so the last one has the 3, and just do the same thing with your factor pairs. 172, 2 times 36, 3, 24, 4 and 18, right? 5's not going to work. 6 has to work because 2 and 3 did. 12, 7, I don't see 7's, 8, and 9. That'd be it. 90 is 1 and 90, 2, 45, 3 and 30, 4 is not going to work, 5, 18, 6, 15, 7 is not going to work, 8's not, 9, and 10. And then 126, 126, 2, 63, 3, 42, 4 is not going to work, 5, no, 6 will, 21 times, 7 is definitely part of it, so 7, take that out anywhere, 7 times 3, so that'd be 3 and 6 is 18, 8's not going to work, 9, 6, 7, 8, it adds up to 9, so 9's going to work. You can take the 2 out of here, and 9 and 14, 10, no. 11, 12, no. So, there's your list. And now, and again, I'd start with my smallest. Do they all have a 72? No. 36? No. Do they all have 24? No. 18, 18, 18, 18, 18, 18. So the greatest common factor is 18. The largest number they all have. And of course, if you did this as a Venn diagram, these aren't so bad. 18 would be the number that they all share. 72 is still missing a 4. 90 is missing a 5. And 126 is missing 7. And none of those have anything in common, so there'd be nothing in those little small areas. Yeah, so that is it. Greatest common factor using factor pairs. And we're going to come back to those. So, next page. So this is the Euclidean algorithm. So that just work through a few of these. I'll show you how it works, but Euclidean algorithm says we can find the greatest common factor if we will see how many times the smaller of the two, I'm going to start with 60, how many times will 60 go into 126, and then what is the remainder? So if you did 126, and you probably want to grab a calculator for this, but you don't want the decimal part. 126 divided by 60, I'll show you that. So 126 divided by 60 is 2.1. So all I care about is how many times it'll go evenly. So it'll go twice. And 60 times 2, if you need to do that with your calculator, is 120. And then subtract. And the remainder is 6. Then take that remainder and see how many times it will go into the smaller number, the 60. And it goes, of course, 10 times evenly, which is 60, and leaves no remainder. Well, once you get to no remainder, this must be the greatest common factor. So the greatest common factor of these, 60 and 126, is 6. So even with bigger numbers, it's all right. Make sure you do the smaller one. So how many times will 572 go into 792? Like I said, if you divide that, 792 divided by 572, it just goes once, which is fine. 572, 792 minus 572 leaves 220. So now, how many times will 220 go into 572? 572 divided by 220 actually goes twice with some remainder, which would be 440, and subtract 572 minus 440, 132. So now how many times will 132 go into 220? And I don't think it'll go more than one time, right? So once, so that's 132. Subtract 220 minus 132 is 88. How many times will 88 go into 132? Again, that's another 1, so 88. 132 minus 88, 44. So how many times will 44 go into 88? And that's twice, exactly, and no remainder. So there's your greatest common factor. So the GCF is 44. All right. If it is 3 of them, 84 or 504, then for the Euclidean algorithm, start with the biggest pair and figure out what is the greatest common factor just between those two. So how many times will 504 go into 1188? Calculate on this side this time. So 1188 divided by 504. It's going to go twice. So 504 times 2, 1008, and subtract 081. So 180. So how many times will 180 go into 504, right? Always bring down your smallest. 504 divided by 180 is twice. 180 twice is 360, and subtract 504 minus 360. 144. So how many times will 144 go into 180? That's just once. 180 minus the 144. 36. And then how many times will 36 go into 144? 144 divided by 36. And it goes evenly, exactly 4 times. So that's your greatest common factor of the first two. 36, right? Now you want to see what is the greatest common factor with 36 and 84. Make the smaller one on the outside, right? So now I'm comparing my answer with 84. 84 divided by 36 goes twice, which is 72. 84 minus 72 is 12. How many times will 12 go into 36? And that's 3 times exactly. So 12, the greatest common factor for the 3 is 12. All right, so try some practice. This time you have the 180 and the 240. Do those. See if you can use the Euclidean algorithm on your own, and then pause and then turn this back on and see how you did. All right, welcome back. So you did smaller. How many times will 180 go into 240? And that will, put it over here, 40 divided by 180 just once. So 240 minus 180, 60. So how many times will 60 go into 180? Well, that goes perfectly 3 times. No remainder, so greatest common factor is 60. All right, so do the same thing with 252 and 540. Try that out before I do it. Welcome back. How many times will 252 go into 540? And for that, you should have got 2 times, which is 504. When you subtract those, you get 36. And how many times will 36 go into 252? Well, it goes exactly 7 times, which is 252. No remainder, so greatest common factor is 36. All right. So try that 3 if you haven't already. Pause, come back. Remember to start with your larger 2 and then work your way down to the third one. So, all right, welcome back. So how many times will 90 go into 126? Only once, because 2 of them would be 180. When you subtract 90, you get 36. How many times will 36 go into 90? And that is twice, which is 72. You get 18 when you subtract those. And how many times will 18 go into 36? That is exactly 2 times. So 18 is the greatest common factor of the first 2, but now I need to check it with 72. So how many times will 18 go into 72? You divide that and you should have got 4 exactly. And since that has no remainder, then 18 must be the greatest common factor of all of them. All right, so that's the Euclidean algorithm to find the greatest common factor for a pair or 3 numbers. So I want to look at the least common multiple. And the least common multiple relates to the greatest common factor when you're going to find it. Least common multiple, what is that first number that both of them would multiply into? And we could list all the multiples of 45 and list the multiples of 72, and then you're looking for that first one they have in common. But let's look at the prime factorization. So 45, again, we're going to get on the screen here, sorry. So 45 and 72. So the prime factorization of 45, I can divide out of 5, which leaves 9, so that's 3 and 3. So 3 squared, 3 squared times 5 is 45. 72, if we do 2, which is 36, and that's another 2, which is 18, is 2, 9, 3, 3. So that is 2 to the third power times 3 squared. So first, if you look at what is the greatest common factor of these two, they both have 3's. It's the only prime number they have in common. And they both have 2 of them. So 3 to the second power, 3 squared. So the greatest common factor is 9. Well, the least common multiple is always going to be your greatest common factor times what you didn't use. So you use the 2 3's here, you didn't use the 5. You use the 2 3's here, you didn't use the 3 2's. Again, if you think about that in the Venn diagram sense, you had the 2 3's that they have in common. The 45 also needs a 5, and the 72 needs 3 2's. Well, this in the Venn diagram, right? Greatest common factor is here, and then the whole thing would be the least common multiple. The or part, if you remember, right? So all of those numbers multiplied together. The 5, the 2 3's, which is the 9, the 3 2's, right? So then 9 times 5 times 2 times 2 times 2. So 360 is the least common multiple using factor pairs. Using prime factorization. If you use factor pairs, 60 is 1 and 60, 2, 30, 3, 20, 4, 15, 5, 12, 6, 10. 84 is 1 and 84, 2 and 42. 3 works. 3 would go twice, leaving 24, which is 8. 4 works. Half of 42 is 21. 5 no. 6 would work because half of 28 is 14. 7 is definitely a factor. 3 times 12, right? So what is the, again, start with the least common multiple. Not 60, not 30, not 20, not 15, 12. They both have 12, right? So your greatest, not your least, let me switch this. Start with your greatest common factor, which is the common 12, and then to get the least common multiple, take the greatest common factor times what you left out of the 60, which was 5, and what you left out of the 84, which was 7. Again, just grab the calculator. 12, 5, 7, 4, 20 is the least common multiple. And again, if you think about this with the Venn diagrams, The 12 was in the middle. The 60 still needed the 5. The 84 still needed 7. Greatest common factor, and then all of those together, least common multiple. Alright, and finally we're going to look at how do we find the least common multiple using the Euclidean algorithm. So, as you remember, we're going to use that same Euclidean algorithm and start with the greatest common factor and then go from there. So first just find greatest common factor, which was divide 45 into 72. 2 of them would be 90, so that'll only go once. 45. So 72 minus 45, 27. So how many times will 27 into 45? And that would only be once. So 45 minus 27 gives us 18. And then 18 into 27. And that will only go once. 27 minus 18, 9. And then how many times will 9 go into 18? That's twice exactly. No remainder. Greatest common factor is 9. So with the Euclidean algorithm, once you find the greatest common factor, the least common multiple will be multiply the two numbers together and divide that by your greatest common factor. So multiply it, so it would be 45 times 72, which is 3240, divided by 9, so 360. So the first number they both go into, 360. So see if you can try that with 60 and 84. Get your greatest common factor and then multiply them together and divide by that greatest common factor. Alright, so welcome back. If you paused, so how many times will 60 go into 84? Of course, that's once. 24. 24 goes into 60. Here. 2 times, which is 48. 60 minus 48, 12. And then 12 into 24. It's exactly twice, no remainder. Our greatest common factor is 12. So our least common multiple will be 60 times 84 divided by 12. 60 times 84, 5040, divided by 12, 420. And that's exactly what we got when we did the 60 and the 84 before. Alright, so with 3, and you can go ahead and try this, but with 3 of them, once you get the greatest common factor, that least common multiple will be the 90 times the 108 times the 144 divided by, and since we have the greatest common factor would be on all 3 of them, you want to divide it out of 2 of them. So you're going to divide it twice or multiply it together, but yeah. So let's get that least common multiple first. That greatest common factor first. So how many times will 108, start with the bigger 2, 108 into 144, should be once. 144 minus 108 is 36. How many times will 36 go into 108? So 108 divided by 36, and it goes 3 times exactly. So 36 is a common factor of the first two. And now, with 90, start with the 36, goes into 90. So 90 divided by 36 will go twice. 36 times 2, 72. 90 minus 72, 18. Then how many times will 18 go into 36? And that's exactly 2. No remainder. So our greatest common factor is 18. So now you'd multiply them and divide that 18 out twice because there's 3 numbers. So you can either put it all in, or see if you understand what I'm going to do. I'm going to multiply them times 108 times 144, divide the 18 once, divide the 18 again. So 4320 is the least common multiple. That would be the same as putting the fraction 90 times 108 times 144 over 18 times 18. Right, because you're dividing them multiply together, but if you're doing it one step at a time, you divide both of them. 4320. All right. So you should be able to open up your assignment and complete your Euclidean algorithm assignment. Have a great day.